Hello friends, welcome to my channel Care for Student. Today I am uploading my first video. If you like it, please subscribe it for more updates. Okay, so for any competitive exams, we have to clear the aptitude. So let's discuss about the number system. What are the fundamental concepts of number system? First one is number. What is number? A number is denoted by a group of digits. We all know that. Let's come to face value and place value. Okay, I will tell you the face value by giving an example. Let us consider an example 6, 8, 7, 2. The face value of 2 is 2, the face value of 7 is 7, the face value of 8 is 8, and the face value of 6 is, yes, you guessed right, it's 6. So what is the face value? It is the number itself. Move to place value. Okay, again we will consider an example 70984. So the place value of 4 is 4 into 1 equals to 4. The place value of 8 is in the tens position, so its value will be 8 into 10 equals to 80. But we have to note that the place value of 9 will be 9 into 100 equals to 900. But we have to note that the place value of 0 is always 0, no matter at what place it is. The place value of 7, yes, can you guess? Yes, you are right. It will be 70,000. Let's move on to the various type of numbers. First of all, let's discuss about prime numbers. Prime numbers are those numbers which has only exactly two factors, namely itself and 1. For example, 2, 3, 5, 7 and so on. What are co-prime numbers? Co-prime numbers are the numbers which has HCF 1, highest common factor 1. For example, 2, 3, 8, 9. What are twin prime numbers? Twin prime numbers are the numbers whose difference is twin, as the name itself said. Example is 3, 5, 5, 7, 11, 13. What are rational numbers and irrational numbers? A rational number is a number which is in the form of P by Q, where Q is not equal to 0. And what is irrational numbers? Irrational numbers are numbers which are non-terminating and non-repeating. Example, root 2, root 3, root 5, pi. These are the irrational numbers. These are the rational numbers. We are going to discuss about the most important topic of this chapter, test for a number to be prime. This is very important. So, how to decide whether a number is prime or not? We are taking an example. Let us consider an example 137. Okay, can you tell me it's a prime number or not? No, not by actually looking at it. So what we do is we take a square of a number which is just greater than 127. Okay, now tell me what is square of 11? It's 121, and 12, it's 144, and we can see that 144 is just greater than 137. Okay, so let us consider number 12. And what are the prime numbers less than 12? 2, 3, 5, 7 and 11. If any of these numbers, any of these prime numbers divides 137, it is not a prime number. But we can see that 137 is neither divisible 2, 3, 5, 7 or 11. So 137 is a prime number. Okay, let's just consider another example. Now let us take another example 214. Okay, by looking at it, you can see that the number is not a prime number. Okay, but let me prove it how. So we'll do the same step. 214, whose number square is greater than 214? 15. It's 225. Okay, and what are the prime numbers less than 15? 2, 3, 5, 7, 11 and 13. but we can see that 2 and 14 is divisible by 2, so 2 and 14 is not a prime number. I hope you all get it. So these are the important formulas. People mainly confuse in these formulas, so please note it down and try to remember it in the examination hall also. For more formulas and concept, please click on the link given in the description below. Now let us solve some questions related to number systems. The first question is 2 minus 2 plus 2 minus 2 plus so on up to 101 terms. So how to solve it? So clearly we can see the given series is such that the sum of any odd number of terms is 2, while that of any even number of terms is 0. Clearly we can see it. So the sum of 100 term is 2, right? So 2 is the correct answer. Now next question, 98th term of the infinite series 1 2 3 4 1 2 3 4 1 2 and so on. So how to find what is the 98th term? Okay, we can see that this is a series of 1 2 3 4 1 2 3 4 1 2 3 4 is repeating itself after every fourth term. So we'll divide it by fourth and find whether remainder is 0 1 2 3 or 4. When we divide 98 by 4, we get remainder as 2. So 98 minus 2, 6. 96 is total divided 4. So 96th term is 4. So what will 97th term? 1. 98th term? 2. So 2 is our correct answer. Next question. If B is greater than A, then which expression will have the highest value given that A and B are both positive integers? Let's consider first option, A minus B. Okay. If B is greater than A, then A minus B is negative, right? Next, AB and A plus B. Okay. So we have two cases, case 1 and case 2. What if I take an example? Take A equals to 1 and B equals to 2. If we take A equals to 1 and B equals to 2, AB is 2, A plus B is 3, and here AB is 2 into 3, 6. AB plus B, 2 plus 3, 5. We can see in the both cases the results are opposite to each other. So we cannot determine what will be the correct answer. So answer will be option D. Next question. If x is between 0 and 1, which of the following is greatest? X, x square, 1 by x square. Okay. Any number between 0 and 1 is, let us consider any number 0.5. Okay. So we can see square of this number will be less than itself, right? 0.25, which will be less than 0.5. So x square is always less than x, and which is less than 1 by x, and which is less than 1 by x square. Are you getting my point? Okay guys, so 1 by x square will be the highest number. Okay, 1 by 0.25, 1 by 0.25 square. You can check it out. Okay, sorry, I made a mistake. Its x value is 0.5. Okay, let's move to next question. Which of the following is a prime number? We have already discussed how to find whether a number is prime or not. So let's take the case of 115, 11th square, 121. Okay, which is greater than 115. So what are the numbers less than prime numbers less than 11, 2, 3, 5 and 7. But 115 is divisible by 5, so it's not a prime number. What about 119? Let's check. 2, 3, 5 and 7 again, but 119 is divisible by 7, so it's not a prime number again. 127, 12 square, 144, which is greater than 127. 2, 3, 5, 7, 11. 127 is equal to 2, no. 3, no. 5, no. 7, no. 11, no. So it is a prime number, right? So option C is the correct. To another question. Product of 82540027 and 423253 is, okay. In such questions, what we do, we eliminate the wrong answers. We can see the product of 7 and 3, the last unit digits, is 21. So what will the unit digit will get after multiplication of these two numbers? 1. So we can check in these four options. In option A, we get the unit digit as 1. So this will be the correct option. Okay. Next question. What is 348 times 265? 8 into 5, 40. The last digit will be 40. We can see all four options carry 0 at its unit place. So we cannot apply the concept we applied in the last question. So what we do in this question is we convert it. How? Let me tell you. We convert 348 as 350 minus 2 and multiply it with 265. Then 350 into 265 minus 2 into 265. We can write 350 as 350, right? Minus 530. Multiplication of 2 and 265 is 530. We can easily multiply 265 with 300 and 50 with 265. After multiplying 300 with 265, we will get this. The product of 300 and 265 is 79500 and 50 into 265 is 13250 minus 530. Now we can easily add and subtract things and we can get the answer as 92220. This option. Now let's move to another question. It is given that 2 power 32 plus 1 is exactly divisible by a certain number. Which of the following is also definitely divisible by the same number? We can see the options. Okay. Now it seems difficult, but it is very easy question. We can consider 2 power 32 as x. So x plus 1 is divisible by a natural number n, right? We can check the options. Okay, 2 to the power 96 plus 1. So what we write? 2 to the power 96. We can write 2 to the power 96 to the power 32 power 3 plus 1. And what is 2 to the power 32? It is x cube plus 1. And how we can factorize x cube plus 1? X plus 1 times x square minus x plus 1. So we can see that this polynomial is totally divisible by x plus 1. So option D will be the correct answer. Thank you for watching this video. If you like this video, please share,